Hello everyone. Today I want to explain a brief introduction to machine learning. So I start by introducing the intuition of machine learning, that is, the basic idea of how a computer can learn patterns from data. Next, I will define machine learning formally so we know exactly what we mean by learning in computational sense. After that, we will look at the main approach to machine learning. Machine learning approaches can be divided into supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. In supervised learning, where models learn from labels examples. In unsupervised learning, where models discover patterns in unlabeled data for finding anomaly and for finding patterns. Semi-supervised learning, which combines a small amount of labeled data with a large amount of unlabeled data. And finally, reinforcement learning, where an agent learns by interacting with an environment and receiving rewards or penalties. So I would like to explain about the machine learning with simple example. The basic idea of how a machine learns from data by trial and error. They use a simple conversion problem predicting miles from kilometers to illustrate the process. In this slide, you can see we know that 100 kilometers equals about 62.137 miles. We start by a random guess, for example, 0.5 miles per kilometer, which predicts 50 miles for 100 kilometers, and the error is equal the truth, the difference between truth and calculated, and the error equals 12.137. So we adjust the guess. We adjust the guess to 0.60 miles per kilometer, and which predicts 60 miles. The error drops to 2.137. And in the next page, you can see trying 0.7 overshoots 70 miles given a negative error. And the error is minus 70.863. So after fine tuning, we say that fine tuning to 0.61 kilometers per miles per kilometer reduces the error to about 1.137. The iterative process, guess, measure error, adjust, is the essence of machine learning. A model improves its performance by continuously updating its internal parameters to minimize the difference between predict outputs and real values. So in this part, I would like to define machine learning. Machine learning means that a computer can improve its performance by gaining experience from data. In formal terms, a computer program a computer program is set to learn from experience E with respect to some task T and some performance measure P. If its performance on T as measured by P improves with experience E. In simple words, the more good data the computer sees, the smarter it gets at that task. It doesn't need explicit instructions for every situation. It discovers patterns and adjusts its internal rules by itself. This is the core idea behind all machine learning methods, whether supervised learning method, unsupervised learning method, or reinforcement learning. The key idea of machine learning is that pattern exists in data even if we don't know the exact mathematical formula. We simply collect enough data about the phenomenon and the computer discovers this hidden pattern so it can make prediction or decisions without us having to write detailed rules. First of all, I would like to explain about the supervised learning. So in this slide explains supervised learning, where we teach a model using data that already has the correct answer or labels, we say that. We know the inputs X and the correct output Y. The model tries to find a function g of x that is almost the same as the true function f of x, such as this. This means we give the computer many examples like pictures of handwritten digits with their correct numbers, so it can learn to predict the right output for new data, for new inputs, and unseen inputs. I mentioned before, we want to find g of x, which approximate target function f. So this part of my presentation and this video consists of examples of supervised learning. This section shows real-life examples of supervised learning to make the concept easier to understand. For example, handwritten digit, handwritten digits recognition, famous dataset MNIST, I will explain, email spam detection, and CFAR 10 and maybe CFAR 100 object classification. These examples demonstrate how supervised learning uses labeled data to recognize patterns and make accurate prediction in everyday applications. So, MNIST dataset. The MNIST dataset is one of the most famous and widely used example of supervised learning. It contains 7,000 grayscale images of handwritten digits from 0 to 9. Each image is matrix 28 times 28 pixels, which means each picture is represented by 784 numerical values, one for each pixel's brightness. And you know brightness is from 0 to 255. In supervised learning, every image comes with the correct label, the digit it represents. During training, the computer looks at many pairs of images, correct number, while comparing its prediction with the true labels. It measures the error and adjusts its internal parameter to improve accuracy. When the training is complete, we can feed the model a new image of a digit it has never seen before, and it will predict the correct number with high accuracy. This example shows how supervised learning can convert raw pixel data into meaningful prediction and is a standard benchmark for testing image recognition algorithms, such as neural networks, multi-layer perceptron, and famous algorithms, convolution neural networks, or CNN. So, another example, this page and this slide describes another supervised learning example. The Wisconsin breast cancer dataset. In this dataset, each record represents a sample describe about 10 key attributes such as cell size, shape, texture, and so on. Each sample is already labeled as either benign or not cancer and malignant or cancer. A machine learning model learns from this label example to classify new samples. The goal is to predict whether a sample is cancerous or not, which is a binary classification problem, and I will explain in future. Because Medical decisions depend on these predictions. High accuracy is critical. Misclassification could delay treatment or cause unnecessary worry. This example shows how supervised learning can directly support healthcare diagnosis, turning patient data into fast and reliable clinical decisions. So, we have several indicators for evaluation the model. Depend to regression model, depend to classification model. For example, in classification model, we have accuracy, recall, precision, and F1. And in this slide, introduces two key measures of model quality, precision and recall. At the first, about the precision. Precision shows how many of the items predicted as positive are actually positive, few false alarms. And how about the recalls? Shows how many of the actual positive items were correctly identified, few missed cases. Another example, email spam detection. This slide shows email spam detection as another real world example of supervised learning. In this task, a large collection of emails is used where each message is already labeled as either spam or not spam. The machine learning model studies patterns such as certain words, phrases, sender addresses, and hidden signals in those emails. By learning these patterns, the model can predict whether a new incoming email is a spam. The key advantage is that the system keeps improving. Whenever user mark new spam, those emails become extra training data, and this continuous learning helps keep inboxes cleaner and protects user from phishing, fraud, and unwanted advertising. This slide is about the CFR10, presents CFR10 object classification, another popular supervised learning example. The CFR10 dataset contains 6,000 color images, each 32 multiplies 32 pixels, these matrices, divided into 10 categories such as airplanes, cars, birds, cats, dogs. Each image is labeled with the correct object it shows. A machine learning model is trained on this labeled image to recognize and classify new pictures. During training, the model compares its predictions with the true labels, measures the error, and adjusts its internal parameters. This example demonstrated how supervised learning powers everyday technologies like photo organization apps, autonomous vehicles, and visual search engine. A closely Related data set is CFAR 100, which has the same size and format, but is much more detailed. Instead of 10 broad categories, CFAR 100 provides 100 fine-grained classes, such as instead of, for example, vehicle, it has separate labels for bus, train, rockets, and etc. Training on CFAR 100 is more challenging and helps build models capable of finer object recognition. Together, CFAR 10 and CFAR 100 show how supervised learning scales from simple to more complex classification tasks, powering applications such as photo organization, visual search, and autonomous vehicles. So, generally, supervised learning approaches can be divided into two parts: classification algorithms, regression algorithms. In classification algorithms, classification predicts a category or class label. For example, spam or not spam, cancer, not cancer. And we want to answer this question: which category? In regression, predicts a continuous numerical value. For example, house price and temperature. And we want to answer this question: how much? So, in classification algorithms, we have several methods. For example, support vector machine, k nearest neighbor, decision tree, random forest, naive Bayes, logistic regression, and neural networks and deep learning. For example, in decision trees, trees split data by features, and random forests combine many trees to improve accuracy and reduce overfitting. In support vector machine, SVM, find the best separating boundary or hyperplane in high dimension data. And in nearest neighbors, predict based on the closest training example. And in neural network and deep learning, layered models that learn complex nonlinear patterns, foundation of deep learning. In regression algorithms, we have several methods: linear regression, multiple linear regression, support vector regression, support vector machine change to support vector regression, polynomial regression, nonlinear regression, and symbolic regression. So, after understanding about the supervised learning, I would like to explain about the unsupervised learning. This slide explains unsupervised learning, where a model finds pattern without label data. Unlike supervised learning, there are no correct answers given in advance. The algorithm explores the data on its own, looking for similarities, grouping, or hidden structure. Key points in unsupervised learning. It reduces human effort since no manual labeling is required. The other, it can uncover unexpected relationship and new insights because we don't have no label we don't have labels. The result may need expert review to confirm their meaning. So generally unsupervised learning can be divided into clustering method, association method, and dimensionality reduction. And I will explain all of this. So before explaining about the clustering, at the first I want to compare supervised method and unsupervised method together. So in this table, you can see many parameters: input data, computational complexity, accuracy, number of classes, data analysis, algorithms used. So, and we want to compare supervised machine learning with unsupervised. I mentioned before, in supervised learning, algorithms are trained using labeled data. But what happened in unsupervised data? Algorithms are used against data that is not labeled. And it is clear about the computational complexity. Supervised machine learning is simpler than unsupervised machine learning. About the accuracy, highly accurate, but in unsupervised learning, less accurate. Data analysis uses offline analysis and in supervised learning, but in unsupervised learning uses real-time analysis of data. So in the previous, I mentioned about the method, for example, linear and logistic regression, random forest, support vector machine, deep learning method, neural network method, k-nearest neighbor, and about the supervised learning. And in unsupervised learning, we have k-means clustering. I will explain hierarchical clustering, one-shot learning, association methods. So at the first, clustering, one of the most important part of unsupervised learning and one of the most important approach is clustering. Clustering is the process of finding similarities among unlabeled data and grouping them together. In many um, books, clustering, which is called cluster analysis, automatic classification, data segmentation, and so on. What is the cluster analysis? Clustering is the process of grouping a set of data objects into multiple groups or clusters, which is called clusters, so that objects within a cluster have high similarity but are very dissimilar to objects in the other clusters. So similarity and dissimilarity is very important in clustering, and number of groups I will explain about this. But generally, please pay attention. Clustering approaches generally can be divided into four groups. The first is partitioning methods. The second is hierarchical methods. And the third is density-based clustering methods. And finally, we have grid-based clustering methods. For example, in the partitioning clustering methods, we have k-means, k-means plus plus, bisecting k-means, k-modes, and k-methods, Clara, Clarence, and Pam. In hierarchical clustering methods, we have several methods and several algorithms, such as Agnes, Diana, Birch, Cure, Rock, and so on. And in density-based clustering methods, we have several methods, and one of the famous method in clustering and in density-based clustering is DB scan. The other examples is optic and Denklu. And finally, in grid-based clustering methods, we have Sting and Click. So in business function can be divided marketing, accounting, finance, and operations. So one of the most important of application of clustering, especially in business, fraud detection, outlier detection, finding anomaly, finding noise, and data segmentation. Is it clear? And you can use several software package such as S+, SPSS, SAS, PyClustering, and scikit-learn in Python. Another method is association. Association rule is unsupervised learning, where algorithm tries to learn without a teacher as data are not labeled. Association commonly used for market basket analysis, which items are bought together. Customer clustering in retail and e-commerce, which store people tend to visit together. Price bundling, assortment, assortment decisions, cross-selling, and others. For example, in this slide, which items are frequently purchased together by my customers? In association, subset of unsupervised learning, we want to answer this question. Another thing is dimensionality reduction. Dimensionality reduction can be divided two parts: feature selection, feature extraction. In feature selection, we try to find a subset of the original set of variables or features to get a smallest subset which can be used to model the problem. It usually involves three ways: filter, wrapper, embedded. But in feature extraction, this reduces the data in high dimensional space to a lower dimension space. We have several methods and famous methods such as principal component analysis, we say that PCA, LDA, linear discriminant analysis, and GDA, generalized discriminant analysis. So after supervised learning and unsupervised learning, at now I would like to explain about the semi-supervised learning. Semi-supervised learning is a learning problem that involves a small number of label examples and a large number of unlabeled examples, and I will explain in future. So after semi-supervised learning, we have reinforcement learning. In reinforcement learning, reinforcement learning is a machine learning training method based on rewarding desired behaviors or punishing or penalty on desired one. In generally, in reinforcement learning agent is able to perceive and interpret its environment, take actions, and learn through trial and error. We have several basic elements in reinforcement learning: agent, environment, state, action, reward, policy, value function, and optional model for the environment. And finally, reinforcement learning can be divided into model-based method and model-free methods. And model-free methods can be divided value-based method and policy-based methods. And in the future, I will explain professionally about the reinforcement learning. Thank you for your attention and for your time. See you in the next video. Bye.